Go over part 2 of this Cisco Expressway training, the solution overview. So we're going to get a little bit deeper in this part 2. So let's get started. So how does Expressway work? Specifically, how does Expressway traversal work? So you'll hear this term traversal, you'll hear the term proxy and things like that. So let's kind of figure out what that is. And since a picture is worth 1,000 words, I'm going to use this picture diagram to explain what's going on and how things work. So let's go through each one of these, 1 through 6. Expressway E is the traversal server installed. Before I go through that, let me say one thing. This concept and this architecture, this traversal thing, is well known. There is a concept if you don't know firewalls very well, there's a concept in firewalls. You can go out from the enterprise. You can go out, but you can't come in, right? And then you can establish connections. So, if I'm browsing a web page or something like that, my user would send a TCP ACK and sync ACK and all that stuff that happens in TCP, but that kind of connection would go out to the internet, connect up, and these firewalls kind of keep a log. They say, this particular PC from this particular IP address was trying to reach this particular IP address on the internet at this particular port. If I see something come back from that particular IP address, and let's get it even more high level. If I see something come back from that particular website, it's obviously this connection bringing that web page back to the user that clicked on this particular website or typed in this URL. So the firewalls usually let things out, keep a log of what's going out, and when things come back, they say this belongs to an existing TCP connection, or this belongs to an existing connection that the user is using to get to this website, and I'm going to let it through, or I'm going to poke a hole back in, or I'm going to poke a pinhole. Maybe it's going to open up another port in the case of media and things like that, and voice or video. So this is kind of the normal how things work when you traverse a firewall that's connecting to the internet. So again, things are allowed to go out. They can't come in. By default, nothing can come in. We have to poke holes in the firewall and things like that. And that's a little dangerous, poking holes in the firewall arbitrarily and just leaving ports open. So again, there's this concept of going out, keeping a log, knowing that something went out, so I'm going to let this other thing come in because it's part of the same connection. And then for the duration of that connection, I'll watch that connection. If it tears down on the transport layer, let's just say if the connection turns down, I don't want to use any technical terms, then it's going to close that particular connection. A firewall will not allow anything back in. Also, if the connection goes dead, maybe your PC bombed out or something, this connection was still up, there's a timer. The timer will go off. There's some threshold, and it's going to close that connection and say, if anyone tries to come back in using this particular connection, I'm sorry, but it's closed. So take that concept. Then we do this thing traversal. So okay, let's start at 1. Expressway E is the traversal server. It's installed in the DMZ. Okay, so it's right here. It's in the DMZ, and it's in a demilitarized zone. Expressway C is the client. Okay, so we have this server, we have a server-client relationship. What does that mean? Let's see. Expressway C initiates, let's just say initiates a connection outbound through the firewall to specific ports on Expressway E using secure login credentials. So in other words, something's happening. We're opening up a connection from Expressway C to Expressway E. Again, things are allowed to go out the firewall to the DMZ. So we bring up this connection. Expressway C initiates the connection. Let's say it logs in for the sake of easier, simple terms, logs into Expressway C. E gives some credentials, so the Expressway E knows that this is a valid connection, and there's some check there that this connection is valid, and this connection can come up. Once that connection is up, well, then we're going to, let's go to 3 here, the keep alive. What's going to happen is, remember I said connections close, connections time out, things like that. There's going to be this green guy right here. This is a keep alive timer. So this keep alive, if this connection is just kept up all the time, so there's something that going on. Let's call it a ping for now. Keep alive. It keeps this connection. Make sure communication is coming from C to E to make sure that connection is up. Now, that connection we're going to depict as this pipe right here. So now we have this pipe up that's between Expressway C and Expressway E. Okay, so when Expressway E, and this particular slide goes through calls. Let's just go through a call. We're not going to do registration yet, but I just want to get the concept of this traversal and this pipe here. So a call is going to come through. So this guy, Jabber, is apparently already registered. All the magic happened for registration, and it's registered over here to UCM and maybe to CUPS also, right? It has IM&P capabilities too. And so there's some signaling that happens for a call, right? That's this red line. So this red thing, this red line, this red connection over here comes to the Expressway E. What Expressway E does is says, hey, I know that this is supposed to go to Expressway C, and where it goes after that, I don't know. Expressway C is going to make that decision. But Expressway E says, I can't make connections from outside the firewall to inside the firewall, so I can't send this through the regular way. But I have this built pipe already that's already secured and already up and ready for traffic. So I'm going to put into this pipe this signaling, this SIP stuff that's going on. I'm going to push it through there to C. Now C looks at this and says, I know where that's supposed to go. That's supposed to go to call manager because that particular endpoint out there is registered to call manager, and I'm just going to forward this on. So there's some magic going on beneath the hood that we're going to uncover. So we're going to pull the onion back slowly, but again, this is basic concepts here. And then that signaling, calls a number. There's a number in the invite, and that number is this guy, and it's going to ring him, and then he's going to answer, and then media is going to begin to flow, and that's depicted by this gray line right here. Now, if you know a little bit about UDP, right, UDP is just going to start flowing one way or the other. I should say UDP, the voice or video is going to flow both ways. Again, if video starts flowing from this Jabber client on the right and starts flowing this way, it's going to flow to this Expressway E. The Expressway E again makes the same decision. I know where this goes. I can't make another connection up to the C, but I have this open pipe already. I'm going to shove it in there. It's going to go across Expressway C. That pipe is already secured. It's encrypted. It's already validated. It's authenticated, and all those cool things that we like to talk about in security speak. And then again, that Expressway C is then going to forward it on to the phone or the endpoint that needs to get that RTP UDP stream. Okay, so hopefully you have that concept. The same concept can be talked about as far as registration when you first bring up this Jabber client out here. It's a little bit more involved, and we'll get to that in a second. Okay, so let's go on to the next slide, slide 17. So what are the protocols that are carried through this traversal? So again, I'm not talking about traversal licenses like we were before. Remember, Expressway and VCS have this concept of traversal licenses, and that's when we're changing from one like SIP to H323 or one codec to another. We're not talking that kind of traversal. We're not talking licensing. We're talking traversing the DMZ. We're talking traversing this secured area in this pipe here. So what protocols can we push through there? We can do XMPP traffic. We can do HTTPS traffic. We can do SIP traffic. Now, all these three, these are capabilities, and then certain certain other capabilities or ports and protocols are used to further this capabilities, like SIP. Once we register, we can do RTP streams, right, using secure RTP streams, but we'll look at that in a second. But these are kind of the, Cisco likes to tout, these are the things that we've added to the Expressway to allow these Jabber clients to come in and register with Call Manager. Again, we'll dive down deeper on that in just a second. Let's go to 18. So what can the Jabber client do with Expressway? If you have Expressway, if you sell Expressway to a customer, I mean, what is it going to do? What's it going to provide? And this is a neat little slide. We can access visual voicemail. So out here in internet land, we have a Jabber client that's on a Windows or Mac PC, and it can access visual voicemail. So we can check our voicemail, we can push play and stop. We have those DVR buttons in there. We can do instant messaging. So we can instant message our colleagues that are inside the firewall over here, or they might be another client hanging off of Expressway out here in internet land. But again, everything is registered back to Call Manager and CUPS back here. We can make voice and video calls. So we can do IM&P, and we can do voice video. We can search our corporate directory. Now there's a little caveat to that we'll talk about later on, but we can search for a corporate directory, and we can from there click to call our colleagues. Of course, look at their presence, green or red, they're busy and things like that. We can share content, so we can use both desktop sharing, which is called BFCP. Now there's two flavors of that, right? We can be in a call with someone, like we call one colleague to another, and then we can push a button that shares our desktop screen. While we're in a call, we can use BFCP to share our desktop. Again, we can, or further, we can launch a web conference. Right? So we can bring up WebEx just like we do internally. It doesn't matter if we're external or internal. We can push a button and bring a WebEx, an instant meeting up right from a Jabber. And then, of course, inside Jabber, we can share content as well. And we can share video as well, and we can connect up to audio conference bridges and things like that. But let's don't muddy the water too much, because those things are kind of disconnected a little bit if you don't understand them quite well. Let's take a look at media paths. So we get questions a lot of times. We get two big questions that are always asked. What are the flows of traffic, and people usually carve those out into two entities. How does it register? What's going on? What's going on through Expressway when this registration happens? And then when we make calls from endpoints, make calls if they're out internet land, and they make calls to an internal phone or internal Jabber client or an external Jabber client that's also in internet land and connected up to the Expressway. What do those media paths look like? So exactly where is my voice and video going is really what we're asking here. So let's take a look at. We have the first scenario, C calls A. So C is a Jabber client, and this A could be a phone, it could be another Jabber client inside the enterprise. So remember, this is the enterprise over here, and this is internet land. So C is going to call A. Now there's signaling that happens depicted by the red stuff here, and then there's media depicted by the green arrows here. So the media is going to flow from the Jabber client right across the internet through the pipe here that we have secured through Expressway E and Expressway C, and then not going to flow through Call Manager or anything like that. It's going to flow right to the Jabber client over here. So that media path looks like this green double-sided arrow here. Now, what if we call from C calls B? So these are both on internet, hanging off the internet out here. They're both registered through C&E to Call Manager, and they call each other. That media path doesn't look so good. It actually goes through Expressway E and C, and it does a turn here. You'll hear that term, turn, T-U-R-N. So it does a turn. So the media, it should tell you something. Media is anchored at the Expressway for each leg. So the media is going to, obviously, the most efficient media path for voice and video would be right from C to E. From C to B. But not in this case. So it's going to go all the way through and come back out. So there's some implications there, bandwidth implications, quality implications. Obviously, we know QoS and things like that doesn't exist on the internet. So those are some things to think about. Now, let's go to the purple here. So let's go to the future. If you're a VCS person, this is in the past, because VCS has always done this between telepresence endpoints. But we have a new product here, and we're not registering telepresence endpoints to VCS control, right? We're registering Jabber and telepresence endpoints to Call Manager, and then we have this new thing, MRA, that we're using. So all these things aren't built in yet, like the most efficient way to get the most efficient media paths. So in this scenario, B calls D. Both B and D are ICE enabled. Okay, so that's a very important thing. ICE enabled. So ICE is a technology that allows a lot of voodoo to go on within the SIP protocol to understand where these endpoints are and what's going on in lower level protocols and higher level protocols, so it can figure out the most efficient media path. So ICE needs to be supported not only by the Jabber clients or telepresence endpoints if you're registering those through Expressway. It also needs to be supported by Expressway, E and C, and also there's some engineering that needs to happen inside Call Manager for all this to work. So there's a lot of things that are going on for ICE to work. So all those mechanisms and things aren't built in yet. They will be built in. I thought I had a note here, but 10.5 is what I understand. Call Manager 10.5 is when the Call Manager will have it. So it doesn't matter if the telepresence endpoints have it or Jabber has it. All of these guys got to be able to have some engineering put in them for all this thing to work. So as I understand it, again, 10.5 is when this ICE support and the most efficient, media path. So something to think about if we're deploying to customers and they're going to be making a lot of voice video calls from outside to outside. They may experience, depending on their bandwidth that's inside their DMZ, they may experience some bad voice quality. They need to be aware of that, or they need to plan for that. Maybe open up those pipes or get those pipes a little bit bigger. Okay, let's talk about what software versions are required today. Cisco Expressway X.811. Again, the Cisco Expressway 8.1, which you might Google and find, did have the mechanisms for MRA to work, but it was a feature that wasn't supported. A feature preview, let's say, and I think that's exactly what Cisco called it. I was grasping for the name, and I think it's a feature preview. So we're previewing this feature. You guys can use it out there if you want to. Don't call us for support, but tell us what you think, kind of thing. 811 now supports it completely, and it's tax supported and all that stuff. Cisco Unified Call Manager 9.12. That's the lowest version you can have to support Expressway. And Cisco Jabber for Windows 9.7. Again, you will find some documentation. When I first started testing this stuff, I was using 9.6. 9.6 did have, let's call it a feature preview, but you had to turn some knobs underneath the hood in Jabber for Windows to make it work. But 9.7 now has all those switches turned on by default and supports registering through Cisco Expressway when it's on the internet. Jabber for Windows, Jabber for iPhone 9.6, and then Cisco Telepresence 7.0 and later. I think some newer presentations you'll see 7.2 or something like that. I tested 7.0 and it worked fine. So no support for Call Manager 8.6. No joy there. And then ICE, Stun, Turn, not supported. These things aren't fully supported until Call Manager 10.0. Not supported in 10.0 and on roadmap for 10.5. I think that's been solidified now and is included in 10.5. All right, moving on. Let's see what we got on Expressway Service Discovery. So you'll hear a lot about this discovery. This is the mechanism that allows you to move in and out of the enterprise. What is it? It's nothing more than a DNS exercise. And simply put, if I'm inside the enterprise, I bring my PC up and I get a DHCP address, and within that DHCP query, I'm going to also ask for DNS, right? So inside the enterprise, we usually use our own DNS service, internal DNS services. Customers do the same thing. When you do this, then after it gets a DNS server, it's going to do a DNS, what we call an SRV lookup. So it's going to look up a service record. It's going to do a DNS query and say, hey, I'm looking for this DNS SRV. It's called UDS._ actually it's underscore Cisco -UDS._TCP.example.com, and this is going to be whatever your domain is. Now your internal DNS, hopefully it's been configured properly, and is going to respond to that and give you the address for that particular service record. So it's going to give you an A record, so to speak. It's going to give you an address. It's going to give you a name for the server and then the IP address for the server as well. So that is what the Jabber client is going to then connect up to. So obviously it's going to connect up to and authenticate to Call Manager. All right. So again, it's a DNS exercise. I bring Jabber up. I'm inside the enterprise. I bring Jabber up, and when I bring Jabber up, there's going to be a service record looked up. We're going to dive deeper into this and look at some traces and see exactly what goes on. But for right now, DNS service record. DNS is going to respond and say, hey, yeah, I got this service record, and here's the server that you need to connect up to. And obviously I'm missing some things here. You know, you're going to get the IP address, you're going to query DNS for the IP address and things like that. And then it's going to look up another DNS SRV. It kind of sends these out in a shotgun blast. So it's going to look up also this _collab-edge._tls.verizon.com or example.com or whatever. And DNS is going to say, I don't have that record. Internal DNS should not have that record. You'll see why in a second. So anyway, we get the DNS record back. We ask for the IP address. We get the IP address for this particular host, and then Jabber is going to say, okay, I know I'm going to connect up to my internal systems. Okay, let me clarify something here. I paused that so you might have seen a little bit of sleight of hand. I changed the names here to make it a little bit easier. So let's stay on this slide for a second. Let me go through this again. So we look up a DNS SRV. When Jabber fires up, it's going to look up this DNS SRV. The DNS server is going to respond with a host name, and then of course we got to turn a host name into IP address, and we're going to do that as well. So I left that out here. So the response here, the host name was called Expressway a second ago. I didn't want you to get confused, so I paused the video and I changed it to CUCM, because when we're internal, Jabber is going to connect up to CUCM and authenticate first with CUCM. Okay? Okay, so let's go on to the next slide here. Now let's look at how things, again, it's high level. We're looking at things, what happens outside the firewall. So when I'm outside the firewall, what happens? Well, Jabber does the same exercise. He asks for this SRV record. He asks DNS. Now, when you're outside the firewall, you're not going to get, when you do DHCP, let's say at home, you're going to get your IP address from your cable modem, and the DNS server that you're going to get is probably your service provider's DNS, not your corporate DNS server. So this time, it's going to ask for the DNS SRV underscore Cisco UDS, the same kind of thing. I'm going to change this to mydomain.com. And then what's going to come back from your service provider's DNS is, I have no record of this. It's not, and I can forward it to you can forward to root servers, and no one's going to know about this DNS SRV out in internet land. The only person that knows about it is your private, your internal DNS server. So it's going to come back not found. And remember, this kind of shotguns out, so it sends all these at one time. Then it's going to look up for a collab edge underscore TLS at, let's say, mydomain.com. That is going to come back because we're going to ensure that the public DNS for our domain responds and has an SRV record for collab edge. So internally, our internal server or DNS servers are going to have an entry for this guy over here, Cisco UDS TCP. External or public DNS, what we're going to register in internet land is we're going to make sure that this is in our internet service provider or our internet facing DNS servers if we take care of our own DNS servers, both public and private, or public and internal. And that's going to come back with, hey, I found, you know, this is the guy you need to contact. And then, change that to my domain again. Then the Jabber client is going to connect, or the first thing it's going to do, because it knows that if I find this collab edge thing, the first thing I didn't need to do is do a TLS handshake and bring this TLS encryption up and do my digital certificates and all that other stuff that we'll talk about later. But I need to bring, let's say for now, I need to bring this encrypted tunnel up to this Expressway E because I'm out in internet land. I know that because I did not get a response for this guy. I got a response for this guy, and that means I'm out on the internet. And then the next thing that happens is an HTTP. Some other things happen here. TLS comes up and things like that, and then we do an HTTPS. Remember, I said one of the protocols that can go through this tunnel is HTTPS. So HTTPS can then get a config from the systems. Okay. Now we're going to take a look at both of these. I'm going to go back one and internal DNS. So as I do this, I want to show you. I know we have demos coming up, but I want to show you this is a DNS server. This is my internal DNS server. We're also going to look at my external DNS server in a minute, but I want to show you my internal DNS server. And look here. If I look, I have a service record for underscore Cisco-UDS. Okay? So if anyone asks my internal DNS server for this SRV record, it exists, and it's going to say, hey, this SRV record exists, and here's the host you need to contact for that service. And you can see this is CUCM. So if I look over here, you can see that I have a CUCM entry as one of my A records right here. So basically the service SRV points to a server over here name, which then again points to an IP address. Okay, and if I had several call managers, I could have several. Obviously I would have 10, 11.0.10, 11.0.11, and things like that. I don't have that in my this lab environment here. So, okay, I think we've learned those two. Okay, what we're going to go through now is some demonstrations. So let's see this in action. Let's again peel back the onion a little bit more. Let's do some traces. Let's do some NS lookups. I'll explain what that is. And let's see what's going on. So the first thing we want to introduce or demonstrate is Jabber inside the enterprise. So a Jabber PC, an iPhone, iPad, whatever, inside the enterprise. How does it do service discovery? Service discovery is how do we figure out if we're in or out of the enterprise. Are we in internet land? Are we inside? And what call manager and cup server and stuff do we authenticate to and register with and things like that. So the first scenario is going to be inside the enterprise. We got an internal DNS server. We have a Jabber client. We have CUCM cups, and we have Unity connection. Okay, so we're going to first do a DNS lookup. There's some, I'm just depicting that with one little line here, doing the service discovery, and then we're going to register or connect. Let's say we kind of register with call manager, and we connect with these other two servers. We always register with our call control. Okay, so let's dive into this. I'm going to bring up two virtual PCs here. Let me get this out of the way because I want to start fresh and new. Okay, so Jack Sparrow here is inside the enterprise, and then we're going to go to Elizabeth Swan over here. She's going to be our outside the enterprise on the internet land. So let's go to Jack. First, let's look at our IP config. Okay, let's do IP config, and let's do all. And what I want you to see here is primary, the DNS server. That DNS server is my internal DNS server. My internal DHCP server served this PC up an IP address as well as default gateway and DNS server. So I have control of my DNS server internally, and I just wanted you to kind of see how this is placed inside the enterprise. So we have our own DNS servers. So remember I talked about service discovery. So what happens with service discovery? Remember we had some DNS lookups that are going to happen. So before we do anything and do some traces, let's look at that. We're using a tool called NS lookup. So NS lookup is a tool that we can via CLI commands execute DNS queries, whether it be an SRV or a host name or something like that. And what I'm going to do is I'm going to set my type here to all. Okay, and if you remember, we're inside the enterprise, and if you remember the service discovery, we just blast. What Jabber is going to do is shotgun blast these DNS queries for these SRV records. So what I want to do here, I'm not going to do them in exact order as what Jabber does, but I want to show you I want to show you one fail. Excuse me. So if you remember outside, let's go look at this again. Outside, we're inside the enterprise here, and this collab edge should fail because we're inside the enterprise. So underscore collab dash edge. All right, so let's take a look at that. Let's do underscore collab dash edge, dot underscore. This is going to be a TLS connection, and then my domain here, demo.net. Okay, if we go look up here, you can see my domain. Well, my internal domain is vzbdemo.com. I have two internal zones. They're both responsible. I'm both the internally. I can respond to both of them, so don't let that confuse you here. So let's see what I get back. I'm gonna ask that. Okay, it tells me right away my particular DNS server does not have a record for this SRV record. Underscore collab dash edge dot underscore TLS dot vzbdemo.net, and we can go look. Let's go look at our DNS server and see for sure. Under vzbdemo.net, I don't have a TLS leaf here, so I obviously don't have any TLS services here. So obviously it came back and said I don't have that. I don't find that DNS SRV record in here. Okay, let's go back. Now the Jabber client's going to try something else also. It's going to try TCP. And if you remember, that was called Cisco-UDS. Okay? And look at that. Right away, I find that record. So the PC queried, just like Jabber is going to query, and then in comes back this SRV record. Here's your service locator. And by the way, in the service locator, here's the port you want to connect up to for this service. Here's the server you want to connect up to that service. So the next thing that's going to happen, Jabber is going to query for that server name. Okay, so server name is CUCM. CUCM 80. And it's going to come back with an IP address. Now my Jabber is going to know what to connect up to. Okay, so I just did some things manually what Jabber's going to do. So let's see it in action for real. Alright, now what I want to do here, since I had already queried this stuff, just to make sure we're cleared out all the caching, here I'm going to flush my DNS. Okay, let's start up a trace. Start that. Okay, we see some things going on there. That's good. And let's start up Jabber. And I'm going to log in. And we see that logs in right away. Let me go ahead and stop this. And let's go see what happened. So let's go way up here. We're looking for what happened with DNS. So right here is our protocol column. And way at the top here, I already see some DNS stuff. And this PC is 107. We look up here, IP config. That's who we should be. Okay, and we see we are 1.107 there, 172.16, 1.107. So we know that's us. All right. So what happens? This PC asks for a query, and look, it's querying an SRV record underscore Cisco dash UDS dot underscore TCP dot vzbdemo.net. Now, I'll tell you how this vzbdemo.net got in there right later on, but I want you to get the concept of what's going on underneath the hood with DNS first. And then, right away, we get a response. So it happened very fast. This DNS response came back and said, hey, I do have an SRV record for what you asked for, and then here are the parameters. So, just like we did manually a second ago, all this came back. Here's the server you need to connect up to. Here's the port, so on and so forth. Now you can see what Jabber did is ask for these other guys too. SRV Collab Edge. Remember, that's the one that he figures out if he's on the internet. So he kind of shotgun blast this whole thing out there. And then we get a DNS response back saying, we don't know, my DNS server, this DNS server does not know anything about this SRV record. It is not in our tables. Okay, and then that's all I wanted to show you there. That is enough, I think, for you guys to get what happened. So right after that, Jabber knows, since he got a response to this _ Cisco-UDS, he knows he's in the enterprise, and he knows to go start communicating with call manager to do authentication and things like that. And we'll see that start to happen. We see it right away. Here there's 11.10. That was in the response over here. Remember, he asked for this SRV record, and then he got the record himself, and then he had to figure out where the server is, and that's down here, but we won't go that far. And then here we go. We start a TCP connection. We start authenticating with call manager, and then we see all kind of things going on between call manager and Jabber. We're doing Active Directory synchronization and authentication, so we start doing that mechanism, and call manager proxies the authentication, blah blah blah, and we get all this communication, and then finally Jabber starts to come up. Okay, fair enough. We also see some communication with CUPS here. That's .12. We'll see some communication with excuse me, that's Unity connection, and then .13 is CUPS. So we see that communication as well, because Jabber's asking call manager authenticates them and does all that business, and then gives them some information on where to connect up to, how and where to connect up to, not only CUPS but also Unity connection. So all that information kind of comes from call manager, push down the Jabber, and then he can continue on connecting up to these other servers and services. Okay, hopefully that is clear as mud. So let's go on to outside the internet. So let's move outside the internet here. Remember, Elizabeth Swan is outside the internet. Let's check here. Let's clear this up here. We're going to do an IP config all, and then we can see that she's on a different network. This network is out in internet land, and the DNS server for that network is Google. That's Google, one of Google's DNS servers. So that's out in internet land. So what we're doing here is going on to this particular scenario. We got a Jabber client out here. The external DNS is Google's out here. Could be one service provider or a service provider, whatever. And then we're going to come in and we're going to try to register through Expressway CNE all the way to call manager, and create the connections, obviously, then to Unity connection and CUPS back here, which I don't have depicted. So let's look at service discovery and registration again. So first thing, let's do an NS lookup again. So let's do this stuff manually to see when Jabber does this stuff, what's he going to get back. We can see that our address is the Google DNS servers. I'm going to set my type to all real quick, and then I'm going to go ahead and do, if you remember, I want to do the one that fails first. We're outside, so let's do the Cisco-UDS dot TCP, excuse me, underscore TCP dot VZB demo dot net. So if we ask for that, if the Jabber application asks for that, what's going to happen? The DNS servers out in internet land are going to say, I have no idea what this is. This SRV record does not exist in the public space. What about we're going to do TLS this time, and we're going to ask for a service record that is called collab-edge. let me just make sure. I get confused on those sometimes. It is UDS underscore collab dash edge. Yes, all right. Okay, I got it right. Let's see what happens. Hey, out in internet land, we get a response from our service provider or DNS servers out in internet and said this service record, this SRB record does exist in the public space. Here is the server that's servicing up that service, and here's the port you need to connect with if you're going to use that service. And then we have some weights and priorities, and we'll go through that later on. So that should, again, Jabber, once he gets this response back, he's going to say, I know I'm out in internet land. I know now I need to register with this server, and I know I'm outside, so I'm going to bring up this TLS, and I'm going to do all this digital certificates and encryption and all this stuff that we're going to learn about later in, I think, part 3. So let's see what it looks like in real life. Let me go ahead and ask Internet LAN also about this Expressway E server. So we're going to do a DNS query for expressway-e.v2b-demo.net. So I'm just asking for this. It told me I needed to connect to this guy. Now I need to know the IP address of that guy. And I did something wrong there. What did I do wrong? Expressway-e.vzb-demo.net. Okay, I have a space in here. I'm not sure what I did, but I did something wrong. Let me type it again. -e.vzb-demo.net. Okay, and there's my answer. I need to connect up with 99.45.109.67. So that just happens to be my external firewall. So the internet address that was given back that I have in my public records is indeed, if we look at this, is going to be this particular firewall's IP address. So he's going to start communicating with that IP address right there. That's the public facing address. You could also have the public facing address right on the Expressway E as well. So let's bring up Wireshark. Let's take a look at this. Let me flush the cache so we can do all this again here. Alrighty. Here we go. Let's go ahead and make sure Jabber is not running. It is not. We're going to go ahead and capture. It's going to start. Let's make sure we see something there. We do. Okay, let's fire up Jabber. Swan. Let me type in her password. We'll let it come up. It's doing this service discovery right now. And it took a little longer, as you can see, because it needed to bring TLS up and those things because it discovered it was outside. Okay, so let's see what happened as far as DNS is concerned. Let's come up here. We're going to see some DNS, and there it is. So we see the same shotgun effect here. We asked for the underscore Cisco -UDS. We immediately got no such name from our DNS servers out in internet land. So then we shot out another one for cup login as well. Again, we'll talk about that later. The two that we're really interested in right now is UDS and Collab Edge. We sent out one for Collab Edge. Again, remember, it just shotguns these things. We got a response for Collab Edge. So now the Jabber client knows, hey, I'm outside internet land. Obviously, I'm going to get the server name that was told to me in this SRB response. I'm going to do a DNS query for that server name. I'm going to get the IP address and so on and so forth. And then I'm going to connect up I'm going to bring up a TLS connection, and that's what you see going on right, starting right here. So here comes the TLS handshake, and then we start this TLS connection, and then once this TLS connection comes up, then everything is encrypted. You know, all these digital certificates happen and everything like that. That's what's going on in here. We're asking and verifying the certificate with the certificate authority and things like that. You see that GoDaddy going on here and stuff like that. So you can see that although we're in internet land, we still were able to log in. We can see our voicemails if we have voicemails, and we can see we can do searches for people internally, like myself or Abraham Lincoln and all those other people that I have in my directory internally. We'll go over directories and things like that because there's some nuances, there's some caveats there as well as far as this technology. Okay, I think that, oh, let me show one thing also. Here's how I can know. There's a little troubleshooting tool here. It's very good. And you can see that my different connections, my registration is up. And you get this little guy right here. It tells you, so the Jabber client tells you you're connected via Expressway. The address you're connected to is the call manager address. It doesn't really show you what's behind the scenes because the connection is really going through the internet to the Expressway E. That's really where the connection is terminated in my environment. So it doesn't show you that. You'd actually have to get a trace and figure that out. But it at least tells you you're connected via internet land via Expressway. And then you can see that voicemail's connected. So these other services, remember I said after the connection comes up, it's call manager that really gives the Jabber client the information to go connect up to voicemail and go connect up to presence. So we connect up to voicemail there, everything's good there, and we connect up to presence, and then we're also connected up locally to our Outlook address book. Disregard that for now. Let's go look at this one. I didn't show you that, I forgot, so let's go back to the on-prem or in enterprise, and we can see that this one is different. See, that doesn't say Expressway. Okay, hopefully that's brought together for you. Let me see if there's any more slides on this. I do have a couple of more, so let's go through these. PKI. So what is PKI? So PKI is a public key infrastructure, and I like this definition because PKI is really kind of an umbrella term as well. So it's a set of hardware, software, policies, and things like that basically needed to create certificates, to manage certificates, to distribute certificates, to use certificates, to store certificates, to revoke them, take them back, it's an arrangement that binds public keys with their respective user identities by means of a certificate authority. So that's a lot of mumbo jumbo. And also PKI works with e-commerce, secure websites, VPN, and Expressway CNE. So that's a lot of mumbo jumbo. The easiest way I can explain it is like a driver's license. You go to the DMV. The DMV, let's say, is just the certificate authority. What does the DMV do? They're going to check. When you go to the DMV to get your driver's license, before they issue that driver's license, they got to check you out. You got to take your birth certificate. You got to take a couple of forms of identification with. They're going to make sure Anson Garcia, you are Anson Garcia. You need to prove to me you're Anson Garcia. So that's kind of what a certificate authority is. After they prove that, they're going to give you a license, and it takes a while, right? It takes a little while. It may take weeks, something like that. But after you go through this certification process, and obviously you're going to take a driving test and all that, but you're going to get this driver's license. That driver's license is going to have your name, it's going to have your address, it's going to have some information about you, your birth date and things like that. It's also going to have stamps on there that, let's say, they're kind of hard to duplicate or something that's going to say Texas DMV. This is issued by Texas DMV, and you can also call the Texas DMV or look up on Texas DMV to see, is this a valid driver's license? I mean, plug in this driver's license number. Is this a bogus driver's license number, or is this a real one? So they kind of keep that, the issuer keeps that information. The other thing, let's take it a little bit further, and we'll try to bring, identity and encryption and all this stuff into it. So we kind of talked a little bit about identity, but all this stuff is kind of stored on your driver's license, let's say, digital certificate, in an encrypted method. And that encryption is kind of locked with a private locked with a private key. Locked with a private key that only a public key can decipher. So hopefully that makes sense. I got two keys, and it takes both of these. I can encrypt with one key, and I can decrypt with the other key. So hopefully that makes a little bit of sense. The analogy, and it's hard to give an analogy of that, if someone gave me if I gave somebody their driver's license, my driver's license, and it was just scrambled, they could take a look at it and have some information on it, but to really look at the identity and look really in it to make sure it's a valid certificate, they'd have to go ask the certificate authority who gave the certificate, who gave that driver's license. Well, Texas DMV. Well, I'm going to call them up, and I'm going to say, hey, send me the public key. Send me your public key. And they'd send me a key, and then I'd put it in this driver's license, and I'd open it up, and everything would decrypt for me. And if it says Anson Garcia, he lives at 4111 North Mill Drive, Magnolia, Texas, and his number is this, and it all looks good, and I can say, okay, I trust you, Anson, because I trust the certificate authority. I trusted the Texas DMV, and with their public key that they gave me, I was able to unlock this security box in your driver's license, and was able to see all this stuff in there, and it looks valid to me. And anyway, you might consider that a lame kind of analogy, but that's the best one I can come up with. And it's more, there's more to it, but I think that's enough to kind of figure out, what's going on here. So the digital certificates used by Expressway. So we have all these certificates, or we have several connections, I should say, that are going on underneath the hood, and let's break them out into the categories. So one is this guy right here, and we'll put that under the category internal, connecting up to Call Manager, Unity, and CUPS. Okay, so that's one type of encryption, digital identity, digital certificates, and things like that you can use. That's one connection. Each one of these are distinct and separate connections. So I can choose to do this connection, and I can choose not to do this connection. Maybe I don't do any encryption internally in my enterprise, and I just install Call Manager by default, and that's cool. I don't. Number one here, I don't want to use digital certificates or anything like that, and everything's out in the open. It's inside my enterprise anyway. Number two, this is the connection between Expressway CNE. Remember, we talked about this client server, and we're going to open up a pipe. We're going to open up this pipe right here, and that particular connection does take digital certificates. It needs to be encrypted. It needs to be identified in identity and authentication, authorization, and all those things need to take place, and we do that with digital certificates. So you can't get away from not doing encryption here. One of the things I like to do in the lab, I always avoid security stuff because I want to see things work. Unfortunately, even in the lab, you can't make things work without going through the digital certificate process and understanding PKI and all these things. In part 5 of this, I know there's 4 parts, but in part 5 I'll be going through all that so for you technical people that want to see how that's done on GoDaddy or CyberTrust or VeriSign, I'm going to actually take the digital certificates, I'm going to go sign them, I'm going to go put them up, and I'm going to wait for them, and we're going to do all that together, and you'll see exactly how this concept and process works. And then we have number 3 over here. So number 3, again, it's suggested that you do digital certificates or public digital certificates, because that's what's just done on the internet. You want this encrypted, you want it encrypted and identified in identity and identified by a public certificate supplier like GoDaddy or CyberTrust, these particular people. So we'll do that as well on part number 5. But here I just want you to understand that there's 3 distinct connections. Number 1, you don't have to do encryption, or you can do internal self-signed if you want, but the main thing is you don't have to do it. Number 2, you do have to do encryption, and number 3, you do have to do encryption. So you have to implore or deploy some kind of PKI and digital certificates for 2 and 3. Okay.